In this part, we'll look at some of the internal parts of a centrifugal pump that you may need to inspect when you're troubleshooting a problem. Unless a pump problem can be solved by adjustments to external parts of the pump, such as the gland follower or the casing bolts, or the system that the pump is part of, you'll need to open the pump and inspect the internal parts to get to the cause of the problem. The pump should be shut down and prepared for disassembly. Whenever you're working on pumps or other machinery, you must make the equipment safe to work on. Following your plant's procedures for locking out and tagging out the equipment will ensure that the pump is not accidentally turned on while you're working on it. If you're not sure about your plant's lockout-tagout requirements, check with your supervisor. For this example, the pump has been moved to the shop for disassembly and inspection. Once you've opened the pump's casing and gained access to the internal parts of the pump, there are several things to look for that could be the cause of trouble. For example, worn or damaged wearing rings will result in discharge fluid leaking back to the impeller's suction eye. As a result, discharge pressure drops and the efficiency of the pump is lowered. Worn or damaged wearing rings must be replaced to restore the pump's efficiency. A clogged lantern ring or gland sealing line prevents essential lubrication from flowing through the packing gland. These situations require a thorough cleaning of the clogged parts. Worn or damaged packing is one of the most common pump problems. If the packing is damaged, it will not provide adequate sealing of the stuffing box, resulting in excessive leak-off out of the packing gland. Packing that is worn, damaged, or inadequately lubricated can also damage the shaft. Packing that is worn or damaged must be replaced. Damage to the shaft can include ridges or grooves cut into it by inadequately lubricated packing material that has become scorched by excessive heat from friction. Before a new or repaired shaft is installed, it's important to make sure that the cause of the damage has been eliminated. Otherwise, the replacement shaft will be damaged as well. Bearing problems can sometimes be detected by rotating the shaft by hand. If there is excessive drag, it could be caused by bad bearings. More often, however, wear or damage to the bearings can only be detected by removing the bearings from their housings and inspecting them. Bearing problems are most often caused by inadequate lubrication. Damaged bearings must be replaced. Besides replacing the bearing, you must eliminate the cause of the loss of lubrication so that the same problem will not happen again. The impeller is the key component of a centrifugal pump because it moves the fluid in the pump. Damage or other problems with the impeller will result in a loss of pump efficiency. The impeller might get clogged by solid materials in the pumped fluid. The impeller might have been mounted incorrectly during an overhaul. Or it could have worked its way loose from the shaft, in which case it would not rotate at all. Another possible problem with impellers is damage from cavitation. Damage caused by cavitation most often appears along the edge of the impeller. The most common problem with impellers is wear that occurs at the point of contact with the wearing rings. This wear can allow discharge fluid to flow back into the suction eye, reducing the pump's efficiency. If the pump was making loud rattling noises while it was running, the casing should be inspected for broken parts or other debris. Foreign objects or fragments of broken parts in the pump should be removed as soon as possible. If they're left inside the pump, they will cause more damage. In this topic, we've examined some general considerations associated with troubleshooting a centrifugal pump. We've looked at some common symptoms that can be observed in an operating pump. And we've looked inside the pump for problems that can only be detected by careful inspection of the pump's internal parts. While the pumps and the parts we've looked at are typical of many found in industrial facilities, centrifugal pumps vary in size and shape and in the specific arrangement of the parts. Always refer to the manufacturer's manuals for specific information when you're working on a pump. Now take some time to try some practice questions on what we've covered in this topic. Into the packing gland, the rings fill the space between the shaft and the casing. Because the packing material is soft, the shaft can rub against it without being damaged. But no matter how soft the packing material is, it must be kept lubricated in order to minimize friction and the resulting heat. Without proper lubrication, the friction caused by the rotation of the shaft can generate enough heat to scorch the packing. And scorched packing could cut grooves in the shaft. Usually, packing is coated with a lubricant such as graphite or Teflon, but additional lubrication is required to protect the packing material and the shaft. In a pump like this one, which pumps water, additional lubrication can be provided by the controlled leakage of water from the area between the shaft and the casing into the packing gland. If more water is needed for lubrication, it can be taken from the discharge end of the pump and fed into the stuffing box through a gland sealing line. In this example, there are 2 sets of packing rings in the packing gland. The lantern ring distributes water from the gland sealing line into the packing gland. In the packing gland of this example pump, there is a lantern ring between 2 sets of packing rings. When the water from the gland sealing line enters the stuffing box, it's forced into the channel in the lantern ring. There are holes in either side of the channel. These holes allow water to escape from the channel and flow into the packing material. Centrifugal pumps that do not use a gland sealing line do not need lantern rings. The gland follower is used to hold the packing gland assembly in place and compress the packing material in the stuffing box. Tightening or loosening the nuts on these bolts adjust the gland follower to exert the right amount of pressure on the packing. The right amount of pressure is important because the pressure controls the amount of fluid that flows through the packing gland. The fluid is used to lubricate the packing material. If the nuts are too tight, not enough fluid will flow through the gland, and the packing material might not be adequately lubricated. If the nuts are too loose, there could be excessive leakage around the pump shaft. The flinger is a collar that is attached to the pump shaft between the stuffing box and the housing for the shaft bearings. The flinger is referred to as a slinger in some plants. It's designed to prevent the controlled leakage between the shaft and the pump casing from getting into the bearings that support the shaft. The shaft bearings hold the shaft in its proper position and allow it to rotate freely. The bearings are supported and protected by the bearing housings at each end of the pump. On this end of the shaft, there is a thrust bearing and a radial bearing. The thrust bearing keeps the shaft from moving back and forth in the direction parallel to the shaft. The radial bearing keeps the shaft from moving up and down or side to side, that is, in a direction perpendicular to the shaft. Another radial bearing is located in the housing at the other end of the pump. The shaft of a centrifugal pump is a carefully machined cylindrical metal bar that transfers the rotational energy from a driver, usually an electric motor, to the pump's impeller. The pump shaft must be properly aligned with the driver's shaft to achieve smooth rotation and the best possible transfer of the driver's energy. The pump's other internal parts are attached to the shaft. Problems with the shaft can be difficult and expensive to fix. So some pump shafts are equipped with shaft sleeves, which can protect the shaft from various kinds of damage. The sleeves fit over the shaft so that if any damage occurs, it occurs to the sleeve and not to the shaft itself. In this topic, we've looked at the main external and internal parts of a typical centrifugal pump. Although most centrifugal pumps have the same basic parts, the size and arrangement of the parts will vary from pump to pump. Now take some time to try some practice questions on this material. In this part, we'll look at some general procedures that can apply to troubleshooting any centrifugal pump. Troubleshooting is the process of identifying and fixing problems. Troubleshooting a centrifugal pump usually begins with a report from the pump operator that there is something wrong with the pump. One of the first steps in troubleshooting a pump is to talk to the pump operator. The operator is responsible for the pump's operation and is probably the person most familiar with the pump's operating characteristics. Important questions you should ask include: what are the symptoms? When did the symptoms first appear? Did the symptoms occur suddenly, or did they develop over a period of time? The timing of the symptoms is very important. If the symptoms occurred suddenly, then the problem is likely to be the complete failure of a part. If the symptoms developed gradually over a period of weeks or months, then the trouble probably involves the gradual wearing out of one or more parts. Other questions to ask are: what steps, if any, has the operator taken to attempt to solve the problem? And did any changes in the pump's operating characteristics occur, such as changes in suction or discharge pressure? Changes in a pump's operating characteristics can also indicate a possible problem in the system that the pump is a part of. For example, a drop in suction pressure might indicate a blockage in the suction piping, or abnormally high discharge pressure could indicate a blockage in the discharge piping. Either of these problems could be caused by such things as clogged strainers, incorrect settings of suction or discharge valves, or even faulty gauges. It's important to be sure that other system components are working properly before you focus on the pump. Remember, anything the operator can tell you about the condition of the pump and the other system components is to your advantage. Unless the problem is so severe that the pump cannot operate at all, you usually will first inspect the pump while it is running.